In the last lecture, we talked about several graphs. We talked about histograms, polygons, and ogives. Today, I'm going to add one more type of graph, a stem and leaf plot. So let's take a look at, so this is scores on a final exam. So I'm going to take a typical data value here. So let's start with this 58. And then I'm also going to look at this 105. So we're going to cut off the very last digit. On each number. So the very last digit is called a leaf. And everything else in front of it is called a stem. And the way you make a stem and leaf plot is, I'm going to first draw a line. On the left side, I'm going to list all my stems. So if I look at my data and try to figure out what are all my possible stems. 58, the stem is 5. 68, the stem is 6. That's an 8. That's a 9. I got some 7s and 10s. So my possible stems here are going to be 5, 6, 7, 8, 9, 10. So I'm going to write down all my stems. 5, 6, 7, 8, 9, and 10. And on the right side are going to be my leaves. And the way you make a stem leaf plot is, I'm going to go through my data and write down the leaf that goes with each stem. So 58 goes with the 5, and we're just going to write down the leaf. So we're just going to write down the very last digit. So I'm just going to write down the 8. Okay, next up is 68. 68 is going to go with the 6. And we're just going to write down the very last digit. 82 goes with the 8, last digit, 2. 92 goes with the 9, last digit is 2. 89 goes with the 8, and we're writing just the very last digit, so that's 9. Another 89 goes with the 8. 78 goes with the 7. 66 goes with the 6. 105 goes with the 10, and we'll just write the very last digit. 82 goes with the 8. 97 goes with the 9. 89 goes with the 8. 70 goes with the 7. Another 70 goes with the 7. 82 goes with the 8. 90 is going to go with the 9. 95 with the 9 again. 84 with the 8. 73 with the 7. 83 with the 8. 85 with the 8. 73 with the 7. 86 with the 8. 100, that's going to go with the 10. And the very last digit would be 0. 80 goes with the 8. 86 with the 8 again. 86 again. And finally 81 with the 8 again. Okay, so that's your initial stem and leaf plot. So technically there's a second step. And technically what you're supposed to do after you have this initial stem and leaf plot is to reorder the leaves from smallest to largest. So since I don't have room here, I'm not going to do that part. But technically, for example, for this 7, you should reorder this to be 0, 0, 3, 3, and then the 8. Okay, part B. Part B says repeat part A, but split the stems using 2 lines for each stem. So actually, before we move on, let me talk about what is a stem and leaf plot? So a stem and leaf plot, if you turn it sideways, it looks like this type of graph. Right? It looks kind of like a histogram. So this is a kind of quick way that you can make a histogram without actually having to draw out the picture. So it's a histogram type graph. Now, what we're doing in part B is, so sometimes if we just use one stem for each number, you get these really tall bars. Okay, so if you have these really tall bars, sometimes it helps the picture to, instead of having 1 5, we'll have 2 5s, 2 6s, 2 7s, 2 8s, 2 9s, and 2 10s. So I have 2 5s, 2 6s, 2 7s, 2 8s, 2 9s, and 2 10s. And then we're going to go through all the leaves and put them, so this 8 is going to go either with the first 5 or the second 5. How do you decide? Well, if you think about the leaves, right, which is the very last digit of your number, it could either be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So half of those will go with the first one, and half of them will go with the second one. So for the first one, it's going to be leaves that are from 0 through 4. And then leaves that are 5, 6, 7, 8, or 9, so 5 through 9, are going to go with the second 5. And then the same for the rest. Okay, so the first one's 8. 8 is going to go with the second 5. Okay, we're now with the 6s. So 8 is going to go with the second 6. 6 is going to go with the second 6. Now for my 7s, 8 should go with the second 7. Then I have 0. So 0 should go with the first 7. Another 0 goes with the first 7. 3. So 3 is between 0 and 4, so it should go with the first 7. Another 3 should go with the first 7. Now for my 8s, 2. Okay, 2 is between 0 and 4, so 2 is going to go with the first 8. 9. 9, it should go with the second 8. Another 9 goes with the second 8. 2, that goes with the first 8. 9, second 8. 2, first 8. 4. 4 is between 0 and 4, so 4 should go with the first 8. 3 goes with the first 8. 5 is going to go with the second 8. 6, second 8. 0 is going to be the first 8. 6, second 8. Another 6, second 8. And then 1 is going to go with the first 8. Now for my 9s, 2 should go with the first 9. 7 is going to go with the second 9. 0, first 9. 5, second 9. And then my 10s, 5 is going to go with the second 10. And then 0 is going to go with the first 10. And that's a stem and leaf plot with split stems. Okay, so now this picture, this is a slightly better picture. You don't have this really tall bar anymore. And then for the second step, same thing, we should technically reorder the leaves from smallest to largest. okay, which I won't do because I don't really have space here. Example 1. Construct a stem and leaf plot for the following data, in which the leaf represents the 100th digit. All right, so let's take a look at a typical piece of data, say this 5.03. Now we're going to cut off the very last digit and call that our leaf. And then everything before it is called a stem. So looking at my data, what are all the possible stems? So 5.0, 4.9, 4.9, 5.0, 4.9. I got 4.8. What else? Looks like it goes up to 5.1. So I think we're going to start with 4.8 and go all the way up to 5.1. Okay, so for my stems, 4.8, 4.9, 5.0, 5.1. Okay, so going through my data, 5.03 should go with the 5.0, and then we just write down the leaf, the very last digit. 4.99 goes with the 4.9, writing just the very last digit. 4.95 goes with the 4.9. 5.01 goes with the 5.0, and we'll just write down the 1. 4.99 goes with the 4.9, we just write down the last digit. 5.03 goes with the 5.0, and we write down the 3. 4.91 goes with the 4.9, and we just write down the 1. 5.25, so I missed the 5.2. So 5.2, and we just write down the 5. 4.80, 4.8, and we just write the 0. 5.24 goes with the 5.2, write down the very last digit. 4.94 goes with the 4.9. 5.04, 5.0, write down the very last digit. 5.17 goes with the 5.1, and we just write down the very last digit. 4.81 goes with the 4.8, last digit is 1. 5.22 goes with the 5.2, and last digit is 2. 4.92 goes with the 4.9, so that's going to be a 2 there. 5.05 goes with the 5.0, it's 5. 4.89 goes with the 4.8. 5.19 there. 5.17. 5.25. 5.14. 5.10. 4.94. 5.19. And 4.99. Okay, and since I do have room here, let me actually do it correctly and reorder the leaves. Okay, so my stems were 4.8 all the way up to 5.2. Okay, so for the 4.8 in order, it's already in order, so 0, 1, 9. For my 4.9, so in order, let's see, it should be 1, 2, so 1, 2, 4, 4, 1, 5, and then 3 9s. Okay, so we're just putting the leaves from smallest to largest. 5.0 is going to be 1, 3, 3, 4, 5. So 1, 3, 3, 4, 5. 5.1, 0, 4, 7, 7, 9, 9. And then 5.2, it's going to go 2, 4, 5, 5. Okay, so technically the second one is the correct answer. So I said if you turn a stem and leaf plot sideways, it looks like a histogram. Okay, so what's the pros and cons of a stem and leaf plot versus a histogram? Okay, this is a histogram from the last lecture. So this is a histogram about how far people live from the airport. So if I give you a histogram, what information can you tell me? What does this 12 mean? This 12 means that there's 12 people who live somewhere between 15 and 30 miles from the airport. And that's really all you can tell me, right? You can't really tell me what the actual numbers are. So these 12 people, they're somewhere between 15 and 30 miles from the airport, but you don't actually know the numbers, right? Now, this is one of the advantages of a stem and leaf plot. If I give you a stem and leaf plot, you can actually go backwards and tell me what the original numbers are. Okay, and this is what we're doing in example 2. So the stems, remember, are the first part of your number. The leaves, each of these leaves are the very last digits. So this first one represents the number, so the stem is 2.8. This first one will represent the number 2.81. The second one represents another 2.81. The 2 represents 2.82. Okay, next we have a stem of 2.9, so that's going to be the first part of our number. The 0 represents 2.90. The 6 represents 2.96. Stem of 3.0, the 2 represents 3.02. The 8, 3.08. Another 8, 3.08. 9, 3.09. Now, what about this? There's no leaf there. What do you do? So if there's no leaf, that means that there's no number that starts with 3.1. So no leaf means no number starting with 3.1. Okay, so don't get tricked. If there's no leaf, there should be no number that starts with that stem, which means the next number is this 4, and this 4 represents 3.24. Okay, so now that you have the original data, you can do things with it like find the average. So the advantage of a stem and leaf plot is that you have the original data. You can go backwards and get the original data. The disadvantage is stem and leaf plots are usually only good if you have a small amount of data. So the two examples that we just did were only like 20 and 30 data values. Okay, if you have thousands of data values, it's going to be a pain to make a stem and leaf plot. That's doing the most. The last two plots that I'll mention very briefly are dot plots and time series plots. For these two plots, we're not going to go through these in detail, just know that they exist. So what I want you to do for these is just stare at them for like a minute or two and just make sure you understand how they work. For example, the dot plot, it looks kind of like a histogram. Just make sure you understand above the 4 here, there's 1, 2, 3, 4, 5, 6, 7 dots above that 4. Just make sure you understand why there's 7 dots. Like, what do these 7 dots represent? I think if you look at the data and stare at the graph, I think it's going to be pretty clear. And then time series plots, I'm pretty sure you've seen these graphs before, so just make sure you understand how to read them. All right, that's it for this section. Have a good day, and I will see you in the next one.